Hi, this is Shakil Ahmed. Welcome to the Spss learning tutorial. In today's tutorial, we will learn how to perform a two-way analysis of variance in SPSS. Previously, we learned how to conduct a one-way analysis of variance in SPSS. In one-way analysis of variance, we compared the means between two or more groups. There were one grouping factor in one-way analysis of variance. For example, if we are interested in comparing mean score of the students between genders, then we can use the one-way analysis of variance, as we have only one grouping factor, that is gender. But in cases when we have two grouping factors, one grouping is row wise and the second grouping is column wise, or we can say that we are comparing the means between gender and the means between age groups, then we can't proceed with one-way analysis of variance. The comparing For the comparison, we use two-way analysis of variance. The two-way analysis of variance has six basic assumptions. One is that the dependent variable should be met at continuous scale, that is interval scale or ratio scale. And second assumption is that the two independent variables should each consist of two or more categories and independent groups. The groups should be mutually exclusive and independent. As I already explained, that one grouping was gender and the other grouping was age groups. And the assumption 3 is that there should be independence between observations, that the observations should be independently drawn from each group and between groups. There should be no significant outlier, that is also a basic assumption of many parametric tests. And the dependent variable should be approximately normally distributed for each combination of the group of the two independent variables. That means for each group or each cell, the distribution of dependent variable should be normal. And the last assumption is that the variance for each group should be homogeneous within group. The group variance should be homogeneous. So we move toward the SPSS, and we want to compare the students score between mean student score between gender of student and the smoking categories. We have two factors. One is student gender and the second is whether the student smoke or not. So we start with the option of analysis and then general linear model, and then click on univariate. We have an independent variable which is student score in subject A, and the two factors which are the fixed factors, gender of students and the smoking category. So you have one independent variable and two independent variable, and then click on plots if you want to draw the plots of scores between student gender and student smoking category, and then add and then continue. And we also conduct post hoc test if the null hypothesis is rejected, as we already done in one-way ANOVA, and the Turkey test is selected for this comparison, and then continue, and then go to the option. We can display overall mean, student gender, and student preference about smoking. And we also display the descriptive statistics. We can also test the homogeneity test. Chi-square test will be performed to uh, check the assumption of homogeneity. We can also plot the residual for checking the normality, and then click on continue, and then OK. And this is the output of two analysis of variance. The first table provide the subject between subject factors, which are gender of student and smoking preference, and this table provide the descriptive statistics for female and male separately, and then the smoking preference as no and yes. Basically this is the mean of female student who don't smoking, mean score, and this is the mean score of female students who smoke. And this test is performed to check the equality of error variance. The null hypothesis is that the variances are equal among groups, and this is significant. Insignificant show that the variances are equal. And this is basically your analysis of variance table, and you need to report the sum of square for student gender, which is this with 1 degree of freedom, and this is the mean mean sum of square, and this is the f value, and this is the p value, and this is the sum of square for second factor, which is student smoking preference, and this is you can also include the interaction if this is insignificant. Unfortunately, all of the factors, the two factors and the interactions are all insignificant, showing insignificant effect on the student score. And this is the error sum of square with 16 degree of freedom, and this is the mean square error, and the f values are obtained by dividing the sum of square by the mean square error. The mean square of the treatment divided by mean square error. And these are the estimated marginal means. This is the grand mean with lower and upper confidence bounds, and these are the gender specific means, and these are the smoking preference specific means, and this is the plot residual plot between different for the two variables with observed and predicted values. The estimated marginal mean of student score in subject A shows that there is no interaction between the two factors. In this plot, we took the gender of student on the x-axis and the smoking preference on y-axis. The no plot is denoted by the blue line, and the yes plot for the plot between gender and estimated marginal mean for yes group is taken as a green line. If the two lines were intersecting each other, then we might conclude that there is an interaction effect, there is a significant interaction effect, and we can also see the interaction effect from the ANOVA, which was insignificant. So these were all about the two-way analysis of variance in SPSS. If you have any question or any confusion, you can ask in comment section, and don't forget to subscribe and share with others. Thank you.